Okay, welcome back. We're talking about init versus systemd. To understand why this was so controversial, understand the philosophy and logic behind the Linux or Unix type of operating system, where you had one tool that did one thing. That was kind of sort of their mantra. If you want something to do two things, well, too bad. We're going to have one tool that does this, another tool that does that. And if you want to do them both, we'll just pipe them together, to make them do both. But so systemd was against that philosophy. It was, we'll take care of it all. And too much, everything that is required to start the system is going to be in systemd. Now, I'll admit, systemd had some pretty cool features, though. One of which was, because it's all being run together, we could do parallel loading, right? While this is happening over here, I could be doing something else over here. And the old system, you just had to wait. It went right down the list. Okay, I'm doing this. Okay, I'm doing this. Okay, I'm doing this. Well, with systemd, I could have 5 or 6 things going on. So in theory, it would boot faster. Okay. So, the disadvantage is it's kind of big and complex. By the way, systemd is not a single thing. Okay, it's not. You don't go hunt for systemd. Systemd is kind of a name for a group of things, okay? So on page 44, they kind of make that point that systemd is not a single application. It's a collection of applications that are tightly bound, okay? So let's go look at some of the files. Let me minimize that guy, bring this guy back up. Okay, cool. So I'm going to go to lib systemd, okay? And then I want to go, let's go to the system, okay, so I just want to look at the, how about rsync? Is that, okay, so I'm going to use VI again, even though I know darn well I don't have permission. It's just familiar for me, so I'm using VI. So I want to look at rsync. Rsync is like a backup command. rsync.service. Okay. So, first of all, does that kind of sort of look familiar to you? The square brackets for a heading and then stuff underneath it? Yeah. This is the old DOS INI files. Wow. When I first saw this, I went, no, that can't be right. Come on. Yeah, they're using DOS INI files. Weird. Okay, so I'm going to go ahead and Q out of that. Cool. Okay, so the first thing we're going to learn is the system CTL. CTL stands for control, system control command. So it's somewhat analogous in the Windows world. You know how in the Windows world you would go to and get like the services tab, right? When you go in and then you could pick, I want to start and stop that service, that kind of thing, right? Well, that's what this thing does. So I'm just going to type one. I'm going to say, oh, yeah. Let me go ahead and go back to my home directory. Okay. So system CTL. And then I want to list unit files whose type is service. Boom. Okay, so this is basically the same thing. This is a listing of all those services that we just saw in that folder and whether or not they're currently enabled, running, or doing something. Okay, cool? Makes sense? I like it. So let's say, for example, that you wanted to create your own service. I don't know why, but just bear with me. Yes, you want to create your own service. Well, there's a couple steps you have to do other than just writing the code that makes the service do. Then you have what's called a unit file. See, unit files, which is this guy that ends with the .service. That guy, remember? Right? So you're going to have to create a kumquat.service. Okay? You're going to have to place it in lib systemd system. And then you're going to have to go in and tell using the system CTL command to enable that particular thing. It'll light up as green like this. Okay? So that's System control is how you start and stop services in the Linux world. Or in this case, how you list all of the files and what their current states are. Cool? Okay. So I'm going to hit Q to get out of that. Okay. So one of the other pieces other than system CTL, there's journal CTL. And journal CTL is how you see the system logs. Now, you've actually seen the system logs before. So if I just type, only if I spell it right, journal CTL. Oh, you've got to be kidding. Did I miss? CTL. Do as I say, not as I do. Does this kind of sort of look familiar? Have you seen that before? Does that look familiar? Yeah, that's the stuff that happens when you boot. So while you're booting, you get to see the kernel logs as they pop up. They're not very useful, but they're turned on by default, so you get to see those things. Okay? Kind of makes sense? So if you want to see, for example, I want to see, if I go down to the very bottom, okay, I probably should get, in fact, hey, why don't I just do that again? No, it's okay. Anyway, let's do this again. And then I want to do a grep on virtual. I don't know if it's virtual or virtual. There you go. Cool. No, that's not what I wanted. I wanted virtual box. Regardless, my point is, you could use this, for example, to find out if the VirtualBox extensions, the VBox extensions, are actually running. Wouldn't that be kind of cool? So, if I want to see if the VirtualBox guest editions are running, I would have to, first of all, I have to find out what the heck it is. Maybe it's VBox, okay? Yeah, there they are. Okay. So there's the devices coming up. Remember how we have the fake CD-ROM and the fake hard drive and the all this stuff, right? The fake kernel controls for the CPU, and then VBox service is running. Yay! Okay. So this is a cool way you can find out if your VBox things were installed correctly. Every time you boot your system, you could, just look at the VBox service guy and see if he's up and running. Cool. Okay, now we kind of sort of talked about reboot and shutdown in other videos, but on page 59 they go through it again. So halting and rebooting a machine there's an awful lot of stuff that happens. We talked about how you bring the system up, but when you bring the system down, you still got almost the same amount of work. There's a lot of things that have to happen. You have to start killing things off, and you have to kill them off in the right order. And then finally, when you get to the end, you have to tell the machine, okay, we're going to shut down. So the shutdown command, the one we've been using, the shutdown space now is what's called a wrapper. It's a wrapper around the halt command. It allows you to send out a message to everyone on the system saying, the system is going down in 5 minutes. And then you can tell it, how many minutes you want to wait. And then you can do a fake one. Shh, don't tell anybody. You can send out a shutdown command and to force people to log off, and then you could say, I changed my mind, and then you can use the shutdown command again to cancel it. Whoo, isn't that cool? Okay, so I'm going to just do man shutdown, and we'll just take a look at this guy, because it's quite a lot of stuff. So halt the machine, power off, reboot. In other words, don't send the message to everyone. And then cancel the pending shutdown. I like that one. The capital C that basically says, hey man, I lied. I changed my mind. Okay. So that's pretty cool. Now the next thing we're going to talk about is let's pretend like you got a Unix system that just flat don't boot. Something's wrong. Okay. I don't know what's going on, but something is messed up. So if you have a non-bootable system, one of the things you have to do is return to a known good state, wouldn't you think? So is there a way that you can boot directly into the shell without actually having, not haul all of the Linux kernel up and running? So what I really want to be able to do is maybe fire up another Linux system, okay? I have two Linux systems. And then from the running one, I mount the file system of the other one. Okay? So I'm running Linux 2 because Linux 1 doesn't want to boot. Something's wrong with it. And so I fire up Linux 2 and then mount the file system for that guy. And then I could go in there and tweak it and, oh, well, I made a mistake when I was doing this, system D file, so I screwed things up, that kind of stuff. And then you could whack it and then move on. So remember we talked about the single user mode. This brings you into a shell and then that's it, okay? So with grub, you can use the single argument. I'm not going to show you, but when you bring it up, you can type, S for single or 1. Another way you can do it is you just basically have to you say init1. That's another way of getting into the single user mode, okay? Or, once again, there's like 3 ways you can do this. Using grub, typing in S for single. Actually, it's dash single. Or init1. Or using the new things we just talked about. Remember the system control guy? I can say system control isolate run level 1 dot target. And that basically says bring me down to the single user mode. Now, when things come up, it'll come all the way up, but most of the stuff is going to be read-only when you do this. All the rest of the partitions, all the disks you have, so you're going to have to remount them. And we haven't really talked about the mount command much. We used it, right, one time, okay? When we were, I'm not gonna use sudo because I'm not actually going to execute the thing. But one of the things you can say when you do a mount is you can say, I want to mount and then O for options. I want to mount read write and then I want to basically do it over again. Remount. What that basically means is, okay, you've already got it mounted, but it's read only, and now all I want to do is just turn right around and mount it again as read write. I don't want to have to go through and unmount it and then turn around and mount it again. I just want to change that from read write to read, or the way around. That's how it's done. Okay, kind of cool. All right, so we have reached the end of the chapter. Thank goodness this was a short one, huh? Right? All right, so you've learned an awful lot about regular expression. You learned an awful lot about the way the system boots up and the init versus system D wars. Okay? We'll see you guys again in some future video.